Hi, welcome to this video on Project 2 titled Straight Line Programs. In this video, I'm going to walk you through the problems in the project and give you some hints on how to go about solving those problems. The goal of this project is to write interesting straight line programs in Python. The zip file for the project, which can be obtained from this site, contains the project specification as a PDF. It contains the starter files for the problems in the project. It contains a test script, and it also contains a template for writing your report for the project. Now, this video is going to be helpful only if you have read the write-up for the project and have a good understanding of the problems involved. So please make sure that you read the project write-up before you continue watching this video. The first problem in the project is called windchill. Here you're supposed to write a program called windchill.py that takes two floats, t and v, as command line arguments. So these inputs, these command line arguments, represent the temperature in Fahrenheit and the wind speed v respectively. And what the program is supposed to do is calculate the wind chill using this formula and print it out. Okay? So first read the two floats, t and v, as command line arguments, and then calculate the wind chill, w, using this formula, and simply write that value out for output. Okay? Now when you need to calculate the exponent, v to the power 0.16, use the exponentiation operator, which is star star in Python. So in Python, when you say something like x star star y, you're calculating x to the power y. The next problem is called body mass index. Here you're going to write a program called bmi.py that takes two floats, w for weight and h for height, as command line arguments, and then the program is supposed to calculate and print the body mass index. All right. So first read the two command line arguments, w and h, representing the weight and height as floats, and then calculate the BMI, the body mass index, using this formula. So BMI is simply the weight divided by the square of the height. Right? And once you have the BMI calculated, simply write it out. The next problem is called polar coordinates. So here you're required to write a program called polar.py that takes two floats, x and y, representing the Cartesian coordinates of a point. And the program is supposed to write the corresponding polar coordinates. All right. So given the Cartesian coordinates of a point xy, you're required to write the corresponding polar coordinates r and theta, where r is calculated using this formula and theta is calculated using this formula. Okay, and once you have r and theta, simply write it out for output. So first read the two command line arguments, x and y, representing the Cartesian coordinates of a point, and then calculate the polar representation, r and theta, using these formulae. Now, when you need to calculate the arctan of a number, use either this formula or this formula. If you use this one, then you need to give it a single argument here, which is y divided by x. And if you use this function to calculate the arctangent, then you need to supply two arguments, y and x. All right, so you don't need to do the division yourself here. Whereas here, you need to do the division and give that as the single input to atan. Okay. The next problem is called order check. Here, you're supposed to write a program called ordercheck.py that takes three floats, x, y, and z, as command line arguments, and writes true or false. It's supposed to write true when the three numbers x, y, and z are in strictly ascending or strictly descending order, and false otherwise. Okay, so first read the three floats as command line arguments, and then simply construct a single Boolean expression that evaluates to true when x, y, and z are strictly in ascending or descending order, and evaluates to false if that's not the case. All right. Now x, y, and z are in strictly ascending order if x is less than y and y is less than z, and x, y, and z are in strictly descending order when x is greater than y and y is greater than z. Okay, so construct a Boolean expression, a suitable Boolean expression, and then simply write it out. The next problem is called day of the week. So here you're going to write a program called dayofweek.py that takes three integers m, d, and y representing the month, day, and year as command line arguments, and the program is supposed to calculate and write the day of the week, which is 0 for Sunday, 1 for Monday, and so on, and it's 6 for Saturday. Right? The day of the week is calculated using these formulae. So y naught is calculated as that, x naught is calculated as that, m naught is calculated as that, and then d, the day of the week, is calculated as that. Okay, and this d is from the interval 0 through 6. Right? So it's 0 for Sunday and 6 for Saturday. All right, so read the three integers m, d, and y representing the month, day, and year as integers and integer command line arguments, and then calculate the day of the week d using these formulae and simply write it out for output. Now notice that all these divisions here that you see are integer divisions. So when you need to perform a division, use the floor division operator, which is // and then here you need the remainder calculated, so for that use the % operator, which is the remainder operator in Python. All right. The next problem is called Mercator projection, and here you're supposed to write a program called Mercator that takes three floats, lambda naught, phi, and lambda as command line arguments and writes its Mercator projection. That is, it writes the x and y values which are calculated using these formulae. Okay. So first read the three floats, lambda naught, phi, and lambda as command line arguments, and then write the Mercator projection, meaning calculate the values x and y using the formulae here and write them out separated by space. Okay. Now when you need to calculate the sine of an angle, use the function mat.sine, but mat.sine expects the angle to be in radians, okay, but this phi was input in degrees, so you first need to turn phi into radians before you call mat.sine, right? And the same here, so keep that in mind. And the way you turn an angle from degrees to radians is using this function mat.radians. All right, and then here you need the natural log of a number, so ln stands for natural log, so for that use the function mat.log. So mat.log is the natural logarithm, right? The next program is called the next problem is called grade circle. Here you're supposed to write a program gradecircle.py that takes four command line arguments, x1, y1, x2, and y2 as floats, and these command line arguments represent the latitude and longitude in degrees of 2 points on Earth, right? And the program is supposed to calculate and print the great circle distance between the 2 points in kilometers, right? And here is the formula for calculating the great circle distance between 2 points, right, in kilometers. So first read the four command line arguments x1, y1, x2, and y2 as floats, and then calculate the great circle distance value d using this formula and simply write it out. Here again, when you need to calculate the sine and cosine of an angle, use the functions mat.sine and mat.cosine, and both these functions expect the input to be in radians. So you need to first turn x1, y1, x2, and y2 into radians, and the way you do that is by using the mat.radians function. All right, and then to calculate the arc cosine, the inverse cosine of a number, you can use the mat.acos function. All right, now acos returns an angle in radians. All right, now what you need to do is before you multiply that value, that return value with 111, you need to turn that angle in radians to something in degrees. And for that, you can make use of the math.degrees function, right? So whatever is returned by a cos, you need to first convert to degrees and then multiply with 111. Okay? And once you have that result, that is the great circle distance which you will write for output. The next problem is called 3-sort. Here you're supposed to write a program called 3sort.py that takes 3 integers as command line arguments. And it's supposed to write them in ascending order separated by space. Okay, and here in this program you're not supposed to use any conditional. All right, and instead you're only supposed to work with the min and max built-in functions. All right, so first read the 3 integers as command line arguments. So let's say these numbers are a, b, and c, and then simply put those numbers in ascending order. So write them in ascending order. Right now, so the way you can do this is first calculate the minimum of the 3 numbers. So the minimum of the 3 numbers using the min built-in function. All right. And then calculate the maximum of the 3 numbers using the built-in max function. And then the way you calculate the middle number is as some arithmetic combination of the numbers a, b, c, min, and max, which you calculated here. Right? So it's some arithmetic combination of these guys. So think about what you need to put in these boxes to calculate the middle number. And once you have the min, middle number, and max, simply write it out separated by spaces. Okay. The next problem is called a random integer. Here you're supposed to write a program called randomint.py that takes 2 integers a and b from the command line and writes a random integer from the interval a through b, where a is inclusive and b is exclusive. Right? So first read 2 integers a and b as command line arguments, and then get a random number, random integer from the interval a to b, where a is inclusive and b is not inclusive. Okay? And to get such a random integer, make use of a suitable function from the random library. And once you have this random integer, simply write it out for output. The last problem in the project is called 3dice. Here you're supposed to write a program called 3dice.py that writes the sum of 3 random integers, each from the interval 1 through 6. All right? And such a number is what you might get when you roll 3 dice. Okay? It's basically the sum of the face values of the 3 dice. All right. So first get 3 random integers, each from the interval 1 through 6. All right? And then once you have the 3 random integers, simply add them and write that result as output. Now to calculate a random integer, to figure out a random integer from this interval 1 through 6, use a suitable function from the random library. All right? Now remember to write your report for the project using the supplied template, report.txt, and then be sure to include the time that you spent on the project. Provide a short description of how you approached each problem, along with any issues that you ran into and how you resolved those issues. If you received help from anyone, acknowledge that in your report. Also feel free to include other comments, such as what you got out of this project, whether or not you enjoyed doing it, and so on and so forth. Okay. Now before you turn in your files, make sure that your programs meet the input and output specification by running this command. All right. And then also make sure that your programs meet the style requirements by running this command. And finally, make sure that your report is not too long. It doesn't contain lines that exceed 80 characters. And also make sure that your report is free of spelling and grammatical mistakes. So that concludes this video on project 2. Thanks for your time.